So just as a quick recap of what we got to last time, we're talking about polynomial functions, we're talking about leading coefficients, degrees, end behavior, all of that key stuff, all the zeros that help us to graph and identify equations from graphs. All right, so the zeros are going to determine the factors, right? So since this is a 0 at -5 and -2, we know that the factors, two factors are going to be x plus 5 and x plus 2. Those are going to be two of the factors because of those zeros. We talked about end behavior. This notation was new for you. This is read the limit as x approaches -infinity. So basically coming from the left, right? So as x approaches -infinity, in other words, as we make the x's go this way, what's happening to the graph? You can see this graph is going up to infinity. So it's expressed like that. And then vice versa, the limit as x approaches infinity, that's going to the right. And you see what the end behavior is doing. It's going down to -infinity. So we would write it like this. Okay. Then we talked about, that's all end behavior. We talked about the leading coefficient, the leading term. That first term tells you a lot about the graph, right? So we have to look at a few things. We have to look at if the degree is positive or negative, if the degree is odd or even, and if the leading coefficient is positive or negative. Those are the two things you're really looking at from your first term. So this is your first term. You're looking at even or odd number and positive or negative coefficient. And we said that when it's odd, it's going to have the same end behavior as, we said, a line. Here it says like an S shape, right? So it does this or this. Just like a line, when it's negative it goes down, when it's positive it goes up. That's going to be odd degree, right? A linear function is a degree of 1, so that's odd, right? And then we said that the even degree has the same end behavior as parabolas, right? Because a quadratic is even. So both up or both down, depending on positive or negative. Okay. We talked a little bit about when this graph bounces off the 0. It just touches it and bounces back down. Then the multiplicity, that was the word for it, right? The number of times that factor occurs in the equation is going to be even if it bounces like that. And it's going to be odd if it goes through, if it just goes through the 0. In other words, here the graph is changing from increasing to decreasing or decreasing to increasing, right? It's basically a maximum or a minimum if it's bouncing off, right? And if it goes through, that's just occurs an odd number of times in the function, and it's just going to go through. Think about the quadratics that we've done. Like, you've been doing them, feels like forever. Let's take that for example, right? That would be like a basic, you've been factoring that since Algebra 1, right? How many times does this factor occur? Only once, right? If it's quadratic, it's once here and it's once there. So we've always been doing, like, it occurs an odd number of times. That's what you're used to. It's an odd number of times, just once. And think about every time you've graphed this. Has it ever bounced off? No. So that's the way, like, I always remember it. Odd goes through, because that's what you've been graphing parabolas forever, right? It occurs once and it goes through. So that's the way I remember that. Okay, and then we talked about, let's do functions, right? Think about L for leading coefficient, D for the degree, And then F, you're looking at the factors. Those are really the three things that are going to help you graph these things and write the equations, etc. So, I had you do these graphs for homework. And there's the first two. Just one of them. So this first one, f of x is x to the third minus 5x squared plus 6x. The first thing you want to do is factor it. Because we don't know what the zeros are until we factor this out, right? If we go in order of our let's do functions, oops, that's not going to let me write on there. L for leading coefficient. The leading coefficient is positive. And the degree, right? L, D. Let's do factors. Let's do functions. That's what I meant. Let's do functions. Right? L for leading coefficient is positive. D for the degree. Degree is 3, and that's odd, right? And then factor. So that's really kind of your approach to these problems. So factor this, and we get pull out an x. You're left with x squared minus 5x plus 6. You can factor that some more. So this is what you end up as your final factored form. That tells you there's 3 zeros, one at 0, right? Set each of these equal to 0. That's 0. One at positive 3, because the factor is x minus 3. The 0 is positive 3. And then one at positive 2. So this says x equals 3, x equals 2, x equals 0. Those are the zeros. Everything occurs once. So every time we graph a 0, it's not going to bounce, it's going to go through the x-axis. So we can start by graphing those zeros. 0, 3, that's 2. It's supposed to be, yes, 2. Yes, you're right, sorry. 2 and 3. Okay, so we graph the 3 zeros. Well, we know that since the leading coefficient is positive and the degree is odd, the end behavior of this function is going to mirror a line's end behavior, right? Because it's odd. And it's positive, so it's going to go down to up, right? So we know we have these 3 zeros. We kind of know it's going to do this. Okay, wow, that was really, okay, really not happy. Okay, well, okay. Let me just, wow, look at this. That is really doing well. Okay. Okay, so we have the zeros. I strategically picked a point halfway between, so that's the point of 1, right? Plug in x is 1 to figure out where this is going to go. Because I don't know how far this goes up. I need to get a point there. So you just pick x is 1 and plug it in. So this is 1 times 1 minus 3 is negative 2. Oh, look, it's over there. And 1 minus 2. We do that out, we get 2. So we know the point 1, 2 is on this graph. That gives us that bump in between the 2 zeros. That makes sense? Okay? And then the same thing here. I picked 2.5. Because 2.5 is halfway between my next 2 zeros, 2 and 3. When I plugged it in, I got negative 0.625. I mean, that's going to be, you know, a little bit more than negative 1/2. Doesn't have to be exact, but at least you know that it's just a little dip down now. And then the rest is just arrows. So we go whoop, whoop, whoop. And that gives us the... Okay. All right, so you did 1 through 4 for homework. We're going to do 5 and 6 together. Or at least 5. We're going to do 5 together. So This is already in factored form. Again, right? Do we know the leading coefficient here? No. Could we figure it out? Yeah. Do we know the degree? What's the degree? 5, right? Because this is x to the third here, times x is x to the fourth, times another x is x to the fifth. So the degree is at least 5. So it's greater than or equal to 5, right? Which means, yep, you don't have a packet. Okay, so the leading coefficient, we don't really need the number of the leading coefficient. We just need to know if it's odd or even. Sorry, positive or negative. This is the odd or even that we're looking for. So this is odd, right? So the degree is odd. Leading coefficient, is it positive or negative? Well, this is a negative 2 to the third. Is that going to be positive or negative? Negative. And then all of these are positive. So the leading coefficient is going to be negative. So I did negative 2 to the third. It's going to give me negative 8, right? And then there's nothing to make it positive. It's just going to stay negative. We could multiply this out, right? And then actually get the leading coefficient. But you don't really need to, because factored form is a lot nicer for graphing, you know, because we know the zeros right away. So leading coefficient is negative, degree is at least 5, so it's odd. What is going to be the end behavior of this graph? Well, since it's odd, does it represent a line-like thing or a polynomial-like thing? I mean a parabola-like thing. It's really... Odd is more like a line. You guys know how I'm getting that? Because a line is a degree of 1, that's odd, right? So lines are odd. So end behavior is going to be like a line. Since it's negative, it's going to go this way. Because a negative slope on a line would go that way, right? So we know it's going to do that. Now, we did the leading coefficient, we did the degree, we got the end behavior from these two things. This gives you end behavior. If we were going to write the end behavior here, we would write it this way. Limit as x approaches negative infinity of the function equals, what's it going to equal? As x approaches negative infinity, so that's left, what's this graph doing? Positive infinity. It's going up. Right? When you're going, okay, so limit as x approaches infinity, so in other words, from the right, this graph is going down. So it's going to negative infinity, right? So when x goes to the right, the graph heads down to negative infinity. Okay, now the zeros, right? Factored form is what we're looking at, and that gives us the zeros. So LD gives us the end behavior, F gives us the zeros. So we're going to have a point at positive 3, at negative 8, and at, what's the zero of that one? 0. Remember, you're getting the zeros by setting each of these equal to 0. Well, negative 2x equals 0, you would just divide by negative 2, you would get 0, right? So that's where our other 0 is. So now we need a chart to get our in-between numbers. I'm going to start with my zeros. Negative 8, 0, 0, 0, 3, 0. It's just a good place to put your zeros. Now let's look in between. What's in between negative 8 and 0? Negative 4. So now we can use a calculator. Sometimes we can just plug it in and do it in our head. But if you plug in negative 4 here, especially to this one, negative 2 times negative 4 to the third power. That's 8 to the third power. Somebody want to do 8 to the third power for me? It's like 512. And then we still have to multiply that by, this is negative 4 plus 8 is 4, and negative 4 minus 3 is negative 7. So we have to do 512 times negative 28. Yeah, it comes out to like something, 12,000 something. Comes out to negative 14,336. The graph and the window a little bit too big, right? So this, all we know is, right, the end behavior does this. So it's going to start up. It's going to come down. Oops, I'm missing my 0. Come down. And it's just going to keep going down. We're not going to be able to graph that. And then it's going to come through here, right? So now we have to figure out where the end behavior, where the peak is between 0 and 3. Well, I plugged in 1. This is negative 14,336. I plugged in 1. I think I plugged in 1. Yep. And I got 144. Still off my graph. So this is going to go up to an ungraphable height and then come down. That's the best we can do here, right? Those dotted lines represent an ungraphable height. But our chart, our XY chart, shows what those would be. Remember that another significant thing that I forgot to mention for this one is how many times each factor occurs. So this occurred only once, so that's an odd number of times. So it goes through. Oops, that's 3. Goes through, right? This occurs only once, so that goes through. This occurs 3 times, which is also odd, so it still goes through. So that's why it just went through, through, and through. We knew that from the end behavior. That's the only way to get all of those anyhow, but it's an important thing to notice. Doing the reverse of this process, you're starting with a graph and writing the polynomial from that. Or you're starting with just information like zeros or whatever and writing the polynomial from that. Okay, so this first one, and there's steps here that you can refer back to. I'll be referring to them as we do this. Okay, so determine a polynomial function that has each set of zeros. More than one answer is possible. So if you have these as your zeros, then we should know that at least these factors occur. What are the 3 factors that we know? Go ahead, Carson. Good. So now if we want the polynomial function, we are just going to multiply that out. Okay, so when you multiply this out, you kind of have to do, distribute, FOIL if you call it that. first, and we get x squared, right? Plus 3x minus 5x is a minus 2x minus 15. And then that times x minus 6. And then we distribute again. X to the third. Distribute the x squared to the minus 6, so minus 6x squared. And then we distribute the negative 2x to everything. So we're going to get negative 2x squared plus 12x minus 15x plus 90. And then if we combine like terms and simplify, our final answer here is going to be f of x equals x to the third. We've got negative 6x squared minus 2x squared is minus 8x squared. And then plus 12 minus 15 is minus 3x plus 90. And that's our polynomial for something with those zeros. If we do part B here, there's a little bit of a trick in this one because it's a 3/4 is a 0. So what's that factor going to look like? Think about when you've ever gotten a fraction as a factor before. What did that original factor look like? So this is going to be 4x minus 3. And then we'll have x plus 3, x plus 4, and x plus 1. So just to think back, right? If you were doing this the opposite way, finding the zeros with these factors, you would take 4x minus 3 and set it equal to 0. And then you would solve. You would get 4x equals 3, and then you would get x equals 3/4. Remember doing that process ever before in your life? Of course you have, right? So that's how the factor of 3/4 came. So the denominator goes in front of the x, right? And then 4x minus 3. Yep. So now we got to multiply it all out. Again, I would FOIL those two. I mean, that's the way I did it. I FOILed those two, and I FOILed those two, and then I multiplied. Okay? I'm not going to do all that out right here, right now, because that's old stuff that you should hopefully remember how to do. Your final answer comes out to this. But you should practice multiplying that out yourself, okay, just to make sure you get the right answer there. I can quickly know if I have the right first term and last term, right? Quickly, I know it's 4x times x times x times x is going to give me 4x to the fourth. And quickly, I know negative 3 times 4 times 1 is going to give me negative 36. At least check those two. At least you know you're on the right track. Okay, so now in reverse of that, write a polynomial function that represents the graph. So if you look back in our little box here, right, determine a polynomial given the zeros, these are the steps we just followed. Write out the factors, and then FOIL it out, and then write the polynomial in descending order, so standard form. Now we're going to do this one. Determine a polynomial given a graph. So use the graph to determine the zeros and their multiplicity. You need to know both of those things from the zeros. So I'm going to start with zeros. And in parentheses, I'm going to put their multiplicity. So when we look at this graph, I see a 0 here, here, and here. So based on the fact that this is counting by 2's, it looks like my first 0 is at -3. How do I determine the multiplicity of that 0? How do I determine? What am I looking at? Yeah, whether it's going through or whether it's bouncing off. And this one's going through, so the multiplicity must be odd. My next 0 is at 2. Again, is it even or odd? Multiplicity. Odd, because it's going through again. And then my last one is at 6. Is that even or odd? That one's even. Now I have to look at end behavior. Those zeros and end behavior. The end behavior of this graph is going down to down. Does that resemble more of a parabola or more of a line? End behavior. Parabola. Is it a positive or a negative? It's a negative. So it's going to be a negative leading coefficient and since it is resembling a parabola's end behavior, parabola is even. So the degree is going to be even. So we could start with these zeros and write them as factors. So f of x equals, actually I'm going to make this first term a sub n, because we don't know what the leading coefficient is. So there's going to be a leading coefficient. I'm going to call it a sub n, right? That's what we called it before. So there is a leading coefficient in there somewhere. We just don't know what that is. We can't tell that from what we've done so far. But we do know what the factors are going to be. X plus 3 because of this 0, right? X minus 2 because of that 0. And x minus 6 because of this 0. Now, based on the multiplicity, right, x plus 3 is odd, so it's okay if we just have it once. That's odd. X minus 2 is also odd, so it's okay that we just have it once. But this one, x minus 6, is even, so we need to put at least a little squared here, because we need it to happen an even number of times. Well, it's not really good enough because we need that a sub n. So if you look at these steps here, right, use an additional point to determine the value of the leading coefficient. Use an additional point. So we have to look at the graph and use a point that will help us determine that first term. So they gave us the point negative 264, so we could use that. That's what I used in my notes that I'm going to post. But I'm also thinking, couldn't we just use this one? It's a little easier to plug in 0, right? Couldn't we use the point 0, 40? Because we can use any point. Avoid using the zeros, right? But let's use 0, 40, see what happens. So my x term is 0 and my y term is 40. Where's the 40 going to go? In the f of x. So f of x becomes 40 equals a sub n. That's what we're solving for. That's going to be our only variable now because now we're plugging in 0 for x. 0 plus 3, 0 minus 2, 0 minus 6 squared. This is 40 equals a sub n, and this is just 3 times negative 2 times 36. And that is 160 negative 2, what is it? Oh boy. That didn't come out the same as when I used the other point. Okay, that's okay. So when you solve for a sub n, then what do you get? Negative 5.4. All right, so if we rewrite our, yep. Oh, that's what I meant to do. Yeah, sorry. Thank you. Bad mistake there. Right, we're dividing by negative 216. I did it backwards. So it should be 216 divided by 40. That's what I meant. That's what I pushed. 0.19. Negative 0.19. Sorry. You guys all catch that? I did it backwards. Divide by negative 216. So it's 40 divided by negative 216. We get negative 0.19. Okay, so then we're going to rewrite our function. F of x equals, our leading coefficient is negative 0.19. And then we just put in our factors. Now, technically, we should multiply that all out. I'm not going to do that right now. At some point, though, you need to practice doing these things, okay? Because you are going to have to multiply some out. Maybe not that many, but at least, 3, maybe 4. Well, this is 4, but it's an ugly one with the 0.19. So we're just not going to do that one right now. All right, so number 3 is the same process as what we just did in number 2. I'm going to have you do that one on your own, and I'll come around and help people who need it. This one's going to bounce. Your final result ended up 0.0. I got 0.04. Some people got 0.05, and that's fine too. I think if you used this point, you got 0.05. But that's not the point I used, so and it has to have a squared with your x plus 6 because it bounces. It's even. Yeah. What did you get? Yeah, it's fine. Yeah. So it should, you guys, it should work. I think that all of these graphs that they're showing us are not like perfectly accurate when you're reading the points. They're not exactly accurate. So That's why there's a little difference. Some get 0.04, some get 0.05. If you used, like I used 1, -7 as my graph, as my point that I plugged in, and I got 0.04. If you used -24, you got 0.05. Somebody else used something else when I was walking around, and they got 0.04. So it just depends, and I just think it's because they're not giving us the exactly accurate thing. Just like on that other one that I was doing in the notes, I got -0.25 last night when I was doing it, and then here we got 0.19. Okay, so it's off a little bit, but I think it's just the accuracy of the graphs that they're showing us. So obviously there's going to be more than one right answer there.